Welcome friends. In today's video, we are starting limitations of wave theory of radiation. Although the wave theory of radiation could successfully explain the phenomena of interference and diffraction, but it fails to explain the following phenomena. The first one is black body radiation, which means emission of radiation from hot bodies, means emission of radiation from hot bodies. The second one is photoelectric effect, that means ejection of electron from a metal surface when radiation strikes on it, means the ejection of electrons from metal surface when some particular radiation strikes on the metal. So we can write this ejection of electrons from metal surface. The third one is the variation of heat capacity of solids as a function of temperature. And the fourth one is the line spectra of atom with special reference to hydrogen atom. So these are the four limitations of theory of radiation, wave theory of radiation, out of which the first one is black body radiation. Black body radiation, an ideal body which is perfect absorber and perfect emitter of radiation, is called black body. The radiation emitted by such body is called black body radiation. So we can say that black body radiations are ideal body and they are perfect absorber and perfect emitter. These are called black body, and the radiation emitted by such body is called black body radiation. The condition should be, it should be ideal body, good absorber and perfect emitter. So these are called black body radiation, which radiations come from these bodies. The second one is when such body is heated, it becomes red. Because the black body heated, then it becomes red. As the temperature further increase, the color of the radiation emitted changes from red to yellow. Means when we further heat the black body, then the red color changes to yellow, yellow changes to white, and white in last changes to purple. Means as the temperature is further increased, the color of the radiation emitted changes from red to yellow to white to finally to purple as the temperature becomes very high. This implies that the wavelength of radiation emitted by black body decrease with the increase in temperature. It means that the frequency of the radiation emitted increase as the temperature increases. The exact frequency distribution of the emitted radiation depends only on the temperature. At a particular temperature, intensity of radiation emitted increase with the decrease in wavelength. So the classical theory does not explain these phenomena. According to classical theory, wavelength of emitted radiation should remain same. Means the wavelength means lambda remain same. However, the intensity might have changed with the raise in temperature. So we can draw a graph which shows the variation of intensity with wavelength in the radiation emitted by black body. So now we are taking a graph or axis. In y-axis we have intensity, in y-axis we have wavelength which is lambda in nanometer, and we have temperature T2 which is greater than temperature T1. So the graph or the curve for the temperature T1 is this one, this for T1, and the graph for T2 is slightly more than the temperature T1. Means the intensity of temperature T2 is greater than the intensity of temperature T1 as the wavelength increases. So I hope you like the video. In next video we will discuss about photoelectric effect. Thank you so much.